All right, so the plan is in the remaining like 37 minutes or so before the break, I will give a quick overview of the key features of the Scenic language. I'll try to keep that relatively short, and then we have time to let you try things out yourself. So I will give instructions for installing Scenic. It's actually really easy, so if you want to try installing it locally, you're welcome to. We also will have Google Colab notebooks that you can try if you just want to do stuff in the browser. Okay, and feel free to stop me here at any time, because I'm just going to try to basically summarize all the key pieces. There will be a bunch, and then we'll switch over to letting you work on examples. Okay, so before I actually talk about the language, I want to start with a little overview of the history, because as Sanjay mentioned, we're going to be talking about Scenic 3. If you look at some of our older papers, there were earlier versions in which things were somewhat different from what I'm presenting here. So just to avoid confusion, I want to clarify that. So we're using the latest version here, Scenic 3. If you look at some of the older papers, as I said, they're older ones. So the very first version of Scenic only let you describe static scenarios. So configurations at one point in time, not how things evolved over time. Then Scenic 2.0 in our journal paper allowed you to describe dynamic scenarios, so things can move and interact with each other in a way that Scenic understands. And this was also when we added a general purpose driving scenario library that lets you write driving scenarios in a simulator agnostic manner. So we had interfaces to Carla, which I mentioned before, and this other driving simulator, LGSVL, but you could write the scenario once and then run it in both of those simulators without any issues. We now have other simulators that use this same library like MetaDrive, which we might show later. And then finally, the current version of Scenic, which is described in this CAV paper from 2023, extends Scenic to have full support for 3D scenarios and the shapes of objects. So for domains such as indoor robotics, previously Scenic didn't know that, for example, the Roomba can drive under the table, but not under a cabinet, something like that. So now you can faithfully model geometry of 3D objects in Scenic, and it accounts for things like occlusion. So if you talk about one thing should be visible from something else, it can actually work that out based on the shape of the object, et cetera. And there are some other nice features in Scenic 3, like the ability to put temporal logic requirements in an LTL-like syntax. Okay, so just a heads up, if you see some of our older papers, the syntax may differ a little bit from what I'm going to show here. Okay, so I'm going to start by giving an overview of how to write static scenarios, and then we'll talk about Scenic's features for dynamics. So this badly parked car example that Sanjit put up before will be the main example I'll illustrate. So what we're going to try to model is what the schematic on the left-hand side shows. So over here on the left, we've got the ego car. This dotted line is showing the view cone of the car. And then over here, somewhere a little bit too far away from the curb and at a bit of a funny angle, we want this badly parked car. Okay. So the way we're going to set this up in Scenic, first we are declaring that we are using the world model, scenic.domains.driving.model. So this is a library that comes with Scenic, which defines everything specific to autonomous driving. So as Sanjit mentioned, there are a bunch of domains that you can use Scenic with. Scenic itself does not have a concept of a car or a road or a lane, things like this. Those are all defined in this library, which we are essentially importing with this first line. Okay, and this is a model which is agnostic to a particular simulator. So we're not saying here we need to use Carla or SVL or MetaDrive. This scenario will work with any of those simulators. So that's the first part. Now we are creating the ego car. We're just saying ego equals new car. So car here is a class, which is defined in this library. It's a class of object. And ego is a special variable for Scenic, which basically defines the object, which is the reference point for the scene. So certain syntax that refers to an object by default will refer to the ego object, but it's really just variable. Notice here, we haven't said anything about where this car is or what direction it's pointing or anything like that. So Scenic is going to use the default values for those properties, position, orientation, et cetera, that are defined in the car class. So in this driving model, if you open it up, you'll see there's a declaration, class car, and in there it gives default values for all of the properties. And these are, so many of them have distributions. So for example, the default position is uniformly random over the entire road network. So you will never get, if you just write this line, you will never get a car on the sidewalk or in the middle of a building. You only get cars actually on the road. But within that constraint, it's uniformly random. So you could get a car on the freeway, some narrow road, etc. The orientation, for example, is also a random variable, but its default value is the nominal driving direction at the position. So you won't get cars facing like backwards on a one-way road. Whenever Scenic will first sample the position of the car and then look up based on the road network, which direction should you be driving at that point? And that will be the direction of the car. So that's the default orientation. And likewise for color and other properties, there are default distributions for those things. Questions so far? Stop me if anything's unclear. Okay, so now the second car is going to be a little bit more involved because we don't just want a completely random car. We want this specifically badly parked car. So we're going to construct that in a few steps. The first thing we're going to do is pick the parking spot for this car. And the way we're going to do that is we are going to pick a random point on the curve. So if we zoom in a little bit here, this red line, whoop, there we go. This red line you see here is the curb region in Scenic. So a region is a primitive data type in Scenic, which just defines a set of points in space. And here the driving model defines a curb region by reading in whichever road network you're running this scenario on and figuring out where the curbs are everywhere. And the union of those is this curb region that we're referring to here. And what we're doing first is we're using a built-in, we want to find the part of the curb which is actually visible from the ego. So this part that I've just highlighted in black. So for that, and then we're going to pick a random point in that region. So we're starting from the curb region, which is defined in this model. We're using a built-in function in Scenic. Visible here is a function that's built into Scenic that takes a region and restricts it to the part of the region that's actually visible from the ego. Okay. And now what's going on here? We are picking a random point in that region using this syntax. So what's going on here is oriented point is a class, a Scenic class, which is built into the language, which, as you can guess from the name, represents a point with a particular orientation associated. And we are constructing an instance of that class using what are called specifiers in Scenic. So the keyword on here is a specifier, which means this point should be chosen uniformly at random from this region, the visible curve. So specifiers, we'll see some more examples of these in just a minute. These are a unique feature that Scenic have for constructing objects, which allow you to specify the properties of an object, like its position, orientation, etc., in a variety of different ways. And you can mix and match them to build up the definition of an object. So the on specifier takes a region and it picks a uniformly random point in it. But there are lots of other specifiers to say, place an object ahead of some other object, place it underneath something, place it offset by a certain amount, place it further along the road by a given distance, etc. So Scenic has quite a few of these, and any of which you can use to construct an object. Okay, so the net effect of this line is we get a uniformly random point along this black region here. And the reason we did an oriented point here instead of just a point is that by default, if you sample a point from a region that has a preferred orientation associated with it, then the point will be oriented along that region's orientation. So here, when we define the curve, we say not only is it a set of points, but it also has an orientation associated with it along the length of the curve. So this actually generates a spot which is on the curve and which is oriented parallel with the curve. And that will be important in just a moment. Okay, so next we are going to pick the angle for this car to be parked at. And the way we're going to do that is using this range syntax, which Sanjit showed earlier. So this range 10, 20 means a uniformly random distribution over that interval. And then we are multiplying that by a uniform choice, a 50-50 choice between 1 and -1, so to left or right. So we're going to have this car be parked at an angle between 10 and 20 degrees, either to the left or to the right of being parallel with the curve. Okay, so now we can actually create the badly parked car. How are we going to do that? So we'll say, create a new car to the left of this parking spot by 0.5 meter. So like this. Left of here is another specifier. So this is a different way to specify the position of an object in Scenic. And this one is notable because this one actually depends on other properties of the object. So for example, if you look at this figure here, if we want a 0.5 meter gap between the right edge of the car and the curb, we need to know how wide the car is, right? If the car was wider, we'd have to place it further away from the curb. So this left of specifier takes that into account automatically. So when you write this, Scenic works out that we first have to sample the width of this car, which will depend on the model of the car. And the model of the car, we're using the default distribution for that because we didn't specify it anywhere, which, if I remember correctly, is like uniformly random over all the different models of car that the simulator supports, something like that. So we're picking the model and then the width based on that, and then we can compute the position of this car given that width. And it's going to be 0.5 meter to the left of this spot, and we don't want it to be like 0.5 meter west. It should be 0.5 meter to the left. So if this curb is not pointing, due north here, right, we want to move sort of north and or west and a little bit north here. So because this spot has an orientation associated with it, this left of is interpreted with respect to that. So we get 0.5 meter into the road and not like 0.5 meter over in the global coordinate system. Okay. And now to set up the angle, we use another specifier here. So facing is a specifier for the orientation property. And we're saying you should face this bad angle relative to the road direction. So what's the road direction? This is another, this uses another primitive Scenic data type called a vector field, which just assigns an orientation to every point in space. Road direction specifically is a vector field defined in the driving model that gives you at every point on the road the nominal driving direction. So we're saying, look up, here we go. Look up the road direction at the car's position, which Scenic is doing automatically here. It says, well, look, we're in the process of defining a car. This road direction defines an orientation at every point. So we should plug in the position of the car. So first we'll sample the position of the car, then we can evaluate the road direction at that point. And finally, this relative to operator is computing what this angle would be relative to that. So you will end up 10 or 20 degrees off of the driving direction and not, due north or something. Okay. So that is actually the complete Scenic program. You can run this exactly as written here. There are a few extra things going on here that we didn't have to write down because they're built into either Scenic or this driving library. So for example, Scenic has some hard constraints built into it, like the fact that objects cannot occupy the same volume. So it will ensure automatically that these two cars do not actually intersect each other. The driving model adds a default requirement for cars that they have to be contained on the road. You can override that if you want a scenario where you've got a car which is, flipped over and by the side of the road or something like that, but that is enforced by default. And here we also had a default requirement, which actually is no longer default, but at the time we made this example, it was that all objects are visible from the ego so that they show up in any images you generate. So Scenic has facilities, which we'll show a little bit later for, I'll get your question, Joe, in just a second. Scenic has facilities for adding arbitrary user-defined requirements, which Scenic will enforce. So it's basically taking the distribution that we defined here in this imperative part of the program and conditioning that distribution on these requirements being true. Joe.
Maybe you mentioned that I missed it, but how do you specify the road topology or?
Yeah, good question. So I glossed over that here. if you try to run this as is, you'll actually, I said you could run it as is, so I lied. If you try to run this as is, you'll get an error saying, hey, you did not specify the map. So this driving model has a way with one more line, you can say load in a road network, which will then, and then the driving model will define roads, lanes, curbs, et cetera, from that. So the main format that we provide an importer for is OpenDrive. People haven't heard of it. It's a standard format for specifying road networks, and which there are tools to interconvert to that and a bunch of other formats. So that's the main one we support. So you can give it an OpenDrive, Scenic an OpenDrive file and say, I want to run this scenario with this particular map. And that will define curb, for example, and road that were used in this program. Yeah.
Okay, hello. Can you see programmatically change the road topology?
Ah, yes. So,
Repeat the question.
oh, yes. So for the recording. So the first question was, how do you specify the road topology, et cetera? So that's what I was answering. The second question was, can we, like within Scenic, create the road topology? This is what you're asking, right? So you can. In fact, we haven't done much with that. But in theory, there's no reason why you can't. You could say something like, all right, let's lay down a road. Now let's have some distribution over, do we want to have it continue straight versus turn left versus turn right, lay down another piece of road, et cetera. I don't think have done any experiments along those lines. And there are other tools which make it more convenient to do that. Like people have used grammars for this kind of thing, for example. But you can do that in Scenic. I think all the experiments we've done have been of the kind of setup where you have a fixed road network and we're positioning objects on top of that. But there's not a fundamental reason why you could not like programmatically, like procedurally generate road networks.
Yeah, I just wanted to mention, to add to that, this is specific to autonomous driving. I think in autonomous driving, given that people tend to define these maps and you import them, that's the basic approach that we followed for defining scenarios. But in other domains, we do it in Scenic a lot more of designing the environment, like in indoor environments.
Yeah, absolutely. So for example, like I think we might show an example later of like a indoor robotics application with a robot like vacuuming a room where we construct the entire room in Scenic. So all the furniture, all the objects, where the robot is, everything from scratch. Yeah.
The software engineering community in their competitions in autonomous driving, the main approach is to procedurally generate road, and this is like used as the input to test the SUTs, the Eagle vehicles. So I think that in some parts, some other communities, it is also common to generate dynamic this kind of roads.
Yeah, and we've seen some tools for doing that, which it would be interesting to do some integration between those and Scenic. For the moment, we don't provide any really convenient features for doing that within Scenic itself. Okay, so other questions about this example? Yes.
This picture on the left is pretty nice. I want to have that in Scenic.
Oh, yes. So those diagrams, the kind of schematic on the left, that is what Scenic produces if you don't connect it to a simulator. So this is what we call the scene schematic, which is like this bird's eye diagram.
After you write this script, you created
it will show that for you, right? But then if you want to actually generate sensor data or simulate physics or something, then you want to connect Scenic up to a simulator to actually run this. But yeah, that is kind of the debugging diagram that Scenic will give you. Yeah. Okay, so right. So then if you do sample some scenes from this, like the diagram I showed on the left was actually a scene sample from that program. But if you connect this up to a simulator, so here this is GTA 5, which you have an interface to, then you can generate actual sensor data. So here, these are camera images from the Ego car, 4 different samples from the exact Scenic program we just saw. And you can see there's a lot of variability in terms of the distance to the vehicle, the weather, time of day, and so forth. But they all meet this high-level description of a badly parked car. Yes.
So besides this info, besides these images, what else do we get from these samples?
Right. So you can generate whatever kind of data your simulator supports. So here we started with just static scenes. We're generating single images. But now imagine you want to actually test your like autopilot for a system. Then you would want to run dynamic simulations. That's what I'm going to talk about next. But we have, in our own experiments, we've gotten RGB images, depth, LiDAR. I don't know.
I think Eddie will talk about.
Eddie will talk about sensor data generation. Like
In the second part, we'll talk about this.
right. But basically, Scenic offloads all of that to the simulator. So Scenic itself is just setting up the configuration and then actually simulating, like doing physics computations or generating data, depends on whichever simulator you get to. So if you are already, for example, testing a system that you develop in a particular simulation framework, Scenic is designed to make it easy to connect Scenic into that, so that if you're already able to simulate your system and have it take in the simulated sensor data and run, it's relatively easy to connect Scenic to that. And Eddie will also mention later, if you want to save this data, like save videos or images, things like that, we've also very recently added some features to make it extra convenient to do that from Scenic, just like one line to save a video or image.
Can I add something?
Yeah.
The fact that you can use Scenic, which is a scenario modeling language, means that you have full control over the content of the scenarios, right? Which means that by generating those scenarios that you have full control over, you can generate different types of sensor data that, as long as those simulators allow you to collect those data. So if your simulator allows you to collect LiDAR sensor data, or radar, or trajectory data, or RGB depth camera, you can collect all those. That's nice. Yeah.
Okay. So I see we're actually running later than I realized. So maybe I'll just quickly go through this part and we can do a brief hands-on part, but then we'll have more time after the break for hands-on stuff because we got plenty of time after the break. Okay, so writing dynamic scenarios. So if you don't want to just only specify the initial configuration for some simulation, but specify how things are changing over time, Scenic has features for doing this as well. So you can describe how things behave and, in fact, how they react to what's going on in the environment. So, for instance, maybe we would like to extend the badly parked car scenario we just saw to say, now, as you approach this car, it suddenly pulls in front of you. So in Scenic, the dynamic part of that, so the actions that the parked car takes over time are specified by giving it what we call a behavior. So we could add a third line here saying the behavior of this car is pull into road. And pull into road is a behavior which Scenic has syntax for defining. So the setup here is that behaviors are essentially functions which run in parallel with the simulation, and at every time step, they can select an action for the agent to take. So the picture is you have these behaviors for your various agents running in Scenic. They send actions over to the simulator, like apply this throttle or this steering, turn on the left turn signal, stuff like that. The simulator takes those and simulates one time. Oh yeah, so for AVs, it could be things like this. It depends on the domain. So Scenic doesn't have any of these built in, but our driving library defines actions like that. For a robotics example, you would have different actions, moving joints of a robot or something, of a robot arm, something like that. Those get sent over to the simulator. And the reason we have these is, again, it allows you to write things in a somewhat simulator agnostic manner. So we don't have to use Carla specific APIs to set the throttle and steering. We can do this purely in Scenic, and then it will work in any driving simulator that we've made an interface for. Okay, so like Carla, SVL, etc. Those receive the actions. Our interface calls the simulator specific APIs. You simulate one step of physics, and then the data, the state of the world comes back into Scenic, and that can now inform the decisions the behaviors make in the next time step. Question?
That like Scenic top-down view display, you didn't have a simulator, release that movie.
Yeah, that top-down view thing is just showing the initial scene. If you want to run a dynamic simulation like this, you have to plug in some simulator. Scenic actually has an extremely simplistic one built in just for debugging dynamic scenarios, but we're kind of phasing it out because it's really bad. We would like people to move to MetaDrive, which, if you haven't used before, this is a popular simulator for like reinforcement learning experiments for autonomous driving because it's very fast, lightweight, much easier to install than like Carla, for example. We've just recently put an interface to Scenic in for that. And so later in the hands-on part, I may show that. So now that lets you basically just you can just do pip install Scenic basically and run dynamic scenarios without having to install extra stuff. We'll show that in the hands-on part. Okay, so here is an example of how you can write a behavior in Scenic. So we're saying this is follow lane behavior. It's like a function. It has an argument here, lane, saying which lane you want to follow. Actually, the real follow lane behavior, it's an optional argument. So you can just say follow, it'll follow whichever lane you happen to be on if you don't specify one. And then what we're doing is we have an infinite loop. At each time step, we run some controllers to pick some throttle and steering as a function of where we are. I've cleared that part out. And now here is the Scenic way to take actions. We have a take statement where we're saying take these two actions, set the throttle to this and the steering to that. And essentially what happens here is when you get to this statement, Scenic will suspend the evaluation of this function, give control to the simulator. Once all the agents have reached the next take statement, we gather all of their actions, send them to the simulator, run one time step, and then resume this behavior where we left off. So here the loop will iterate, we'll compute a new throttle and steering, etc. So that's the very basics of behaviors. There's other things you can do. The main interesting construct that Scenic provides are interrupts, which give you a way to add special cases to behaviors without having to open them up and change them. So you can take a library of behaviors, like the follow lane behavior that Scenic provides, for example, and customize it. So here I've got a follow lead car behavior where I'm saying, try follow lane behavior. So the do statement here basically invokes a sub behavior. So it says, run this follow lane behavior. While that is running, monitor this condition, the distance to this other car being less than the safety distance. If that condition ever happens, is satisfied, then we suspend this behavior and instead we run this other behavior, collision avoidance, which maybe will, apply full braking, something like that. And then when this behavior finishes, if this condition is no longer true, then we will resume follow lane behavior where we were before. So this is essentially doing like a subsumption architecture type thing where we're running the follow lane behavior, but whenever some condition is met, we switch to some other behavior temporarily, and then we go back later. So that's a very useful construct for making more complicated kinds of behaviors. You can also add temporal requirements, things like you can say, for example, the taxi should always stay in the lane, and let's reject any simulations where the taxi leaves the lane. Or eventually the pedestrian should be visible from the ego. So we'll throw out any simulations where the pedestrian, always remained hidden for some reason. So it might be difficult to arrange things so that this always happened, but we can tell Scenic to enforce this and it will automatically reject any simulations where that does not hold. Okay, so as an example here, this is inspired by scenario from this OAS Voyage set, where we have a lead car which is periodically stopping and starting, and the ego car behind it has to brake to avoid a collision. So I'll take this follow lead car behavior, which we just saw, and I'm going to write this stops and starts behavior. And what I'm doing here is I'm picking a random delay of between 3 to 6 seconds. And I'm going to remember the last time we stopped, just using some variable here, so behaviors can maintain their own local state. Question there.
This stop delay, is it initialized each time that you call the stops and starts behavior?
That's right. That's right. Each time, but when we're going to run the scenario, this is only going to get called once. And then the whole scenario, we're going to be inside like this later part here.
But if you call this arrange something within a sub
oh yes
module,
then it would be every time. That's right. That's right. So here I've written it so that we're picking this once and then we're going to have the same like period every time. But if you wanted to independently do it each time, we could kind of push that down inside this loop. Yeah. Okay, and then we're saying, let's do the follow lane behavior until the current time minus the time when we last stopped. So the time elapsed since then is greater than this, in which case we're going to brake for 5 seconds and then update this variable saying the last time we stopped. Okay. And then I'm setting up the geometry here. We have a couple of cars. We're going to put the lead car 10 meters ahead of the ego. And just to make sure we don't, we have like a straightaway ahead of us, I put in a requirement. So this is the way you can add like user-defined requirements, saying that 100 meters ahead of the ego should still be in the road. There are more sophisticated ways you could do this to make sure you don't have an intersection in front of you, et cetera. But this was just something simple. Okay, and I put in a termination condition. If the ego ever leaves the road, like is not in the lane anymore, then we'll terminate the scenario at that point. Okay, so here is that scenario running in Carla. So you can see the car in front stops, and then the car behind braking is activated. And then it will start again and stop. So that's an example. And in fact, this code, same code that I just showed, you could run in MetaDrive, for example, without any changes. It's not actually Carla specific. Okay. So I wanted to say a bit more. Let's see. We only have a few minutes before the break. Maybe we should. Should we skip the? I have a few slides more on more sophisticated, advanced scenic features, but we could do it afterward. Or I could just. Yeah. Okay. So then let me skip that and just tell you about how to get going with the hands-on part. Which, if you want to start setting up now, you can. Otherwise, we'll do more when we get back from the break. So first of all, this is our main website from which we have links to documentation, our user forum, if you want to ask questions about using Scenic, etc. And the documentation is there, which has extended versions of the tutorials that we're doing today, plus others. There's detailed syntax guide, like API for using Scenic as part of some broader tool, like doing verification, falsification, and also documentation on how to interface Scenic to a new simulator. If you have one that you're already working with, but which we don't have an interface for, it's relatively easy to do that. And I mentioned the forum. I'll also mention that maybe I will show in the second part, but we had a workshop on Scenic in August, a 2-day workshop with longer versions of these tutorials and a lot more on kind of the inner workings of Scenic and how to hook new things into it, etc. And we have the recordings from all of those on YouTube. We have a playlist. It's linked to also from this website. Okay. So here is installing Scenic in one slide. As I mentioned, we also have some Colab notebooks, and I'll put up a QR code for that in a second if people want to try those out. But if you would like to try running Scenic locally, there's this getting started with Scenic page in our documentation, and it's very straightforward. I mean, the short version is if you want to get the absolute latest version from the repository, you clone the repository right there. You can create a virtual environment if you don't already have one that you want to use. Turn it on. You can update your version of pip just to make sure you have the latest version that doesn't cause any problems later. You can do an editable install of Scenic, the second to last line, and then you're done. Now you can start running some of our examples that are in the repository. So if people would like to try this, do that. I will put up the QR code for people to pull up the notebook as well. If people have, say, got the URL here, docs.sceniclang.org. Okay. So the notebook is here. I think, do we actually, we should add the link to I think we might have probably forgot to add the link to the workshop, the tutorial page.
You want to do?
Let me see if it's there already.
Oh, we had that.
Maybe we did. Maybe we did.
If you go to sceniclang.org /CPS25, then you'll get the workshop page.
Here, I'll
But then that page didn't actually have.
You didn't have the thing yet?
no, okay, here.
So we can put the links there.
Yeah.
Yeah, let me
Yeah, let me-
are you going to do it, Eddie? Or
Yeah.
Okay. Let me show where the page is for that. So, oops,
I use the same one
I'm
from
trying
the
to.
CPPI.
Here we go. Okay, so if you go to sceniclang.org, right, this is our main. It's bigger. So this is our main website. If you go to events here, then there's this CPS page, and we will add the link in here. Because I don't, yeah, we forgot to put the link in here, but we'll add it.
Can you?
Okay. Do we have it? Actually, maybe we just, is it the same link that's in the CVPR one? It probably is, right?
Yeah.
Oh, yeah.
Yeah.
Yeah. Okay, so actually we could just, maybe this is even easier.
Yeah.
If you just go to, from under events here, CVPR 24, where we had the earlier version of this tutorial. There are links in the schedule here to the two notebooks.
Yeah.
Well, so since we're basically at the coffee break now, so feel free to go to the coffee break. I'll hang around at least if anyone needs help getting the notebook working, or you want to try installing Scenic yourself. When we start up back again at 4, we'll give you some time to actually work hands-on in the notebook or on your computers, and then we'll move on to more advanced use cases for Scenic. Should we pause the recording? Is it already? Okay, so hi everybody again. We've updated the workshop website page with the links to the Colab notebooks. So if you would like to do that rather than trying to install Scenic locally, let's start with this notebook 1, static scenarios. That's the one I had the QR code for earlier. So if you open that up, you'll see, whoops. It should look like this. And there are instructions on how to do everything. It's totally self-contained. So you ought to be able to just run the first box and it will install Scenic in this thing. One thing to note in the notebook, it's rather slow. So it may take a couple of minutes to run some of the things. If you want to try installing Scenic locally, following the instructions that I gave before, I'm happy to help, wander around and help people do that. But this has some small examples where we'll walk you through creating objects. So like here, it's bigger. So, here we just have create a single object, and it's not rendering here because I have to restart this thing, but you'll get like a 3D view of that object. And then we'll walk through, specifying more properties of the object. So now we can give it some specific dimensions, specify the orientation, the shape, that kind of thing. And we'll build up to some fairly complicated things by the end. Okay, here, some of these are showing up. So like here's a cone with random direction, positioning some more interesting shapes like aircraft here. We talk about how Scenic provides facilities for doing all that, all this sort of thing. And then at the end, there are some exercises.
Did you show that you can grab it and turn it around?
I'm not sure it's going to work, but let me see. Oh yeah, there you go. So you can grab these, change the camera angle, etc. And then if we get to it, there are some examples down at the bottom where we ask you to try doing things like you could use a loop and create a pile of 10 cubes stacked on each other. Something like that. So give this a try. I will put back the okay, does everybody have the notebook link pulled up? Okay, then I will skip this and I will just go to the cheat sheet here. And go through we have the syntax guide in our documentation that lists everything, but this I've tried to put all the key parts on a single page. So you can see the built-in classes in the top left with their main properties like position and so forth. And then here are the most commonly used specifiers. So you can position things at a specific point or above some other object or left of there or in some region, etc. Lots of different things like that. The basic kinds of distributions that are built in. You can put requirements where you require some condition holds, some of the kinds of operators that typically come up, etc. So I'll just leave this up here. Please give the notebook a try and try working through those, and I can mill around and answer questions or help people see and install if you want to do it locally instead of in the browser. And we'll do this for another 10, 15 minutes or so.